Hello mathematicians, and welcome back to Solving Systems. We're continuing with solving by graphing. So please make sure you have this flowchart worksheet in front of you. And take a second and pause this video to copy down these two problems. Okay, I'm guessing you copied it down. Now remember, we have to read step 1. Look at the equations. Are they both in y equals mx plus b form? What does that even mean? Well, this means that y is on one side all by himself. So looking at this equation, is y by himself? No, it is not. It is a plus 2 right there. Looking at the second equation, is y by itself? No, it's not. It has this negative x there. So now we're going to go to the left of the flowchart where it says no. And what we're going to do is we're going to copy down these problems again. And we're going to get it in mx plus b form. So that's the first one. So let's write down goal. You want to get y by itself. That is my goal here. I just want to get y by itself. But in order to get y by itself, we have to go over something called inverse functions. Hopefully this is kind of ringing a bell. Now, with every single operation, not inverse functions, I am so sorry, inverse operations. Now, with every operation, there's an opposite one. So if I add something, if I give you $2, I can make it $0 again by taking it away or subtracting it. If I multiply something, so if I have $1 and I double it, you have $2 now. I can undo it by dividing. So if you have $2 and I split it in half, you're back to one single dollar. I want you guys to keep this in mind as we're working through this. So step 1, I'm actually going to make a T-chart so I can organize my work. And by this I mean I'm going to draw a line on where the equal sign is. So back to my problem. What are the things that are next to y? So the first thing we have is this 2, and we have a negative. Think about it like y wants to isolate itself, but it has two very annoying siblings. Which one do we knock out first? We're going to knock out the one that is the farthest away from it, which is going to be this 2. This negative is right next to it, so we have to get rid of this 2 first. Now remember, we have to look at the operation. This 2 is adding, so to get rid of it, I have to do the inverse operation, which is subtract. So I'm going to do minus 2. But what I do to one side of the equation, I have to do on the other side, which is where this green line is going to help me. I'm going to go minus 2 right here. Now, 2 minus 2 becomes 0. All right. So I get to bring back down my y. So I get negative y. That's 0, so I'm not going to write it. Now on this side, I have negative x minus 2. I don't know what x is, so I can't even combine it. So I'm going to bring both of it down. Negative x minus 2. Is y by itself yet? If you said yes, then you are wrong because we still have this pesky little negative sign here. You tried hiding. Now, when we have a negative like this, there's actually a negative 1 right beside it. It's actually saying negative 1 times y. So how do I get rid of it? I have to do the opposite of a multiplication, which is division. So right here, I'm going to divide by negative 1. Remember, we want to get rid of the negative. And what I do to one side, I have to do to the other side. So right here, negative 1 divided by 1 becomes 1 giant 1, and it crosses out. My y comes down finally by himself. But on my right-hand side, I got to clean this up a little bit. What I'm actually going to do is I'm going to treat my negative 1 with each one. So I'm going to focus with negative x divided by negative 1. What's x divided by 1? Any number divided by 1 is just, well, x. Any number divided by 1 is itself, right? 5 divided by 1 is 5. 5 divided by 4 is 4. But I have a negative and a negative. A negative divided by a negative gives me a positive. Now let's focus on our 2. What's 2 divided by 1? Well, 2 divided by 1 is just 2. And again, I have a negative and a negative, which gives me a positive. So now this is y equals mx plus b form, because y is by itself. So this is our new purple equation. Let's go ahead and go a little faster with our second one. 2y minus x equals 6. All right, I'm going to draw my equal sign. My divider, let's say. Now again, my goal is to get y by itself. But I have this 2 and this negative x that is stopping it from being it by itself. So which one do I take care of first, 2 or negative x? Remember, I always have to take care of the most outer operations first. So in this case, it is the negative x I need to take care of. What is x doing with y? What's this symbol right here? It's subtracting. So to do the opposite, I have to add by x. And what I do to one side, I have to do to the other side. So last, my 2y comes down. So I'm left with 2y on my right side. And then I have x minus x is a 0. Awesome, I wanted to get rid of that, remember? But on my right-hand side, I have 6 plus x. Can I simplify that? No, I cannot. I don't know what x is. X could be 0, x could be 20. We don't know what it is. So we're going to bring it back, all of it down. Is y by itself? No, it is not by itself. I still have this 2. So what is 2 doing with y? Remember that when they're close to each other like that, they're actually multiplying. So to get rid of it, I have to do the opposite of multiplying, which is dividing. And what I do to one side, I do to the other side. 2 divided by 2 is 1. Let me cross this out. My y comes down. And on this right-hand side, I have x divided by 2. Remember, I don't know what x is, so I'm just going to bring down that whole thing. And then I have 6 divided by 2. Well, I know what that one. That one's 3. Oops, I messed up right here. So this is going to be my new blue equation. Now that they're in y mx plus b form, now I can write my equations. So my purple one, my y-intercept is this one right here. So I'm going to go to plus 2 on my y-axis. And now there is an imaginary 1 in front of my x, which is my slope. But remember, we have to make it into a fraction. So that's telling me that I have to go up 1 over 1, up 1 over 1, up 1 over 1 for all eternity. Okay, awesome. Now for my blue line, again, we start with the y-intercept. So I'm going to start at positive 3. And now my slope looks a little funny, okay? It's x over 2. But what you can do is you can actually move the x down. So I have 2 right here. And what I'm left with is a 1 at the top. Because remember that there's always an imaginary 1 next to every x. So now I can easily see my rise and my run. So I'm going to go up 1 over 2, up 1. Oh, I think I did that wrong. Plus 3, 1, 2, 3. Up 1 over 2, up 1 over 2. There we go. And that's going to be my line right there. So as you can see, they're intersecting at this point right here. And what is that point? We're looking on my x-axis. This is 1, and this is 2. So my first point is 2. And then looking at my y-axis right here, this is 1, 2, 3, and 4. So my answer is 2, 4. Now you can go ahead and check it. So we're going to use our pulpable equation. Y equals x plus 2. And our blue equation. Y equals x over 2 plus 3. And you're going to plug in our solution answers to make sure that they work for both equations. So now you know how to graph equations that are not in mx+b form. So go ahead and jump onto Delta Math, and I'll see you for the next video.